No one enjoys repetitive tasks. This is why in this chapter 2 of our Python for Finance free course, we're exploring the power of loops. These really help eliminate repetition, optimizing our coding time and efficiency. Let me give you an example. Say I wanted to print numbers from 0 to 19. I could manually write code for each number. That will require 20 separate lines of code, with each line being almost identical, except for the number in the parenthesis. However, with a loop, I can achieve the same result using just 2 lines of code. Quite cool, right? This example was very simplistic, but I'm sure you get the point. Now with loops comes another fundamental notion, and that's conditions. So let's have a look at all of that together, and remember that there is a written version of this course available on our website. Check the links in the description below. Let's start by defining briefly what is a loop before we play with them. So a loop is a basic structure that allows you to repeat a task several times. In the example that I showed in the introduction, what was repeated several times was this print I. So basically, I was iterating, thanks to this line here, in numbers between 0 up to 19, and I was printing I at each step. That is why we get this print of 0, 1, 2, etc. up to 19. So you see, I've mentioned 2 important words that are key for loops: repetition and iteration. Great. As you can see here, this loop starts with a for, and this is what we call a for loop. And the other fundamental loop is what is called a while loop, and this is really linked to conditions. So conceptually, you would use it like this. You would say, while something is something, do this. And we'll look into that in a minute, but that's really the spirit of a while loop. It will check a condition and it will do something until a given condition is met. And that's why in the second part of this chapter, we are going to look into conditions. And notably, you might know this already or heard of it. We will look into all these if, else conditions, etc. Okay, time to get started. Let's create a new file. We'll call it chapter 2, and we'll stick to a Jupyter notebook, hence the extension IPyWayneB. Great. So let's do a practical example to get started. Let's say we want to compute how much we'll have in our bank account in a year, given a salary that we get every month. So let's say that at the moment, my bank account, I already have 2,500 whatever, let's say dollars. I'm calling it wallet to be faster. And our salary, let's say that this will be 1,800 US dollars. So if I start writing my for loop, I'll go for I in, wait a second, guys. That would be too easy, right? I'm forgetting something important, I think, here. We always have those bills. Of course we do. So we'll have to subtract that every month as well. So let's say we have $700 worth of bills every month. Okay, so let's get back to this. So I'll do range 12 because we're looking into 12 months to compute how much we'll have in our bank account after 12 months. So I'm writing range 12. And then to finish this line is very important. You always finish with a colon, okay? Then I press enter and I can start my computation. So I will add to my wallet my salary. So I'm going to say wallet is equal to wallet plus salary. And as we said, we have to deal with bills. So I'm going to do next line, wallet is equal to wallet minus bills. There we go. Probably what I must do is at the end print what is the value of wallet. So we get our results after 12 months. Okay, let's run the code and we'll see what we get. I'll select the correct kernel and there we go. 15,700 US dollars. Great. In case you don't know me, I'm Louis. And on this channel, we aim to democratize algorithmic trading and quantitative analysis in finance. So if these topics resonate with you, I encourage you to subscribe, but also join our community Discord. Links below. I went a bit fast to write all of this, so let's take a little moment to analyze things in details a bit more. First thing I said was very important is that to finish this for instruction, you need to put a colon. Very important. The other important thing you should have noticed is that when I pressed enter, VS Code didn't actually put me back to the line here, but it actually made me start at the line 4 spaces after the beginning. This is what is called an indentation, and this is of paramount importance in Python. What this means is that this block here is actually a child block of this parent block here, if you want. So that means this is in the for loop, while this one that is here below and not indented is back into not being in the for loop anymore. Let me show you by adding simply print wallet here so you'll understand. So this print wallet has the indentation, therefore it is part of the loop. So if I run the code, well, we indeed have a print at each step of the loop. So we see how our bank account grows every month. Nice. And you see the last month, the last print was of this amount. And indeed, because we have another print here right at the end and outside of the loop, we have the same amount. Great. Something else I didn't explain yet is what is this range function? Well, basically, when you write for I goes in range of 12, I is basically going to start at 0 until 11. So maybe to show you that better, I could simply write a print I here and put it correctly indented here. Let's actually do better than that. Let's not put it here. Let's put it here with a comma. So we will see the I and the wallet corresponding at each step of the loop. Great. So we see it starts from 0, goes up to 11. Now, maybe this wallet equals wallet thing could be a bit confusing to you. So what am I doing here? Well, you have to remember at the first step of the loop, what is wallet worth? Well, wallet was defined here and is equal to 2,500. So what I'm saying is that now the new wallet should be equal to the old wallet. And to that, you add the salary. Okay. So at the end of this line, once this is executed the first time at the first step of the loop, we have the wallet being equal to 2,500 plus our salary. But then next line, I'm saying to that wallet, subtract the bills. So it will be 2,500 plus 1,800 minus 700. And that we printed the result, and it is indeed equal to $3,600. And what happens at the next step of the loop now? Well, the wallet is worth 3,600 at this point here. So to that wallet, we add the salary. And then again to that wallet, we remove the bills, which gives us at the end of these operations, the wallet worth of 4,700, etc., until the end, until the 12th month, where we get to a total of 15,700. By the way, you can see that I wrote these 2 lines to make things quite clear, but it is true that it is not necessary. I could have simply put everything on one line and just wrote it like that. And this would have yielded the same results exactly, as you can see. Let's also do our print a bit nicer. So let's say on month, and I'm going to put that in between quotations, so they're strings. So let me do this. On month I, comma I open a new string. My bank account holds, then another comma, and I'll have wallet. So let's run that. On month 0, my bank account holds 3,600. We did say that it was USD, so let's be precise and put USD here. Great. Another improvement we could do is maybe start at month 1 rather than 0. This is very important, by the way. In Python, the first element of anything is always 0. It is not 1. That is why I in range 12 starts at 0. But if we want to change that so we display 1 at the first iteration here, we could totally put 1, 13. So let's run that. And you can see I could also delete this space here so it looks nicer. On month 1, my bank, etc., etc. Final thing, just to insist again, if I remove the indentation here, then you will see we print it only once because it will be printed once the loop is over. So the indentation is key.
Okay, I think we've covered enough of the for loop and we're ready for the while loop. I know this might seem like a lot already, but don't worry. With practice, it becomes really natural.
Let's also work with a practical example here. Let's say we want to compute how many years it will take us to double an investment that has a given yearly interest rate. So let's define our starting variable. So let's say that our initial investment, I'll just call it initial wallet, is of, let's say, $1,000. Then let's say that the interest rate is of 5%, so 0.05. Great. So we will now initialize our counters. So we need to count how many years it's going to take. So we are going to put years is equal to 0 here and say that our current wallet is equal to what at the beginning? Well, to our initial wallet. Great. So now we can start writing our while loop. And how are we going to implement a condition? So what we're looking for is for the computations to happen until we've doubled our initial investment. So what I'm going to do, I'm going to say, well, do the while loop until my current wallet is smaller than 2 times my initial wallet. So what this is going to do, beg your pardon, this should be just a times. 2 stars, by the way, means power, but we just want the multiplication. So 2 times initial wallet. And as you can see, very importantly, I finished the while instructions with a colon. So basically what we must understand here is that the while loop will carry on as long as the current wallet is smaller than 2 times the initial wallet. Or in other words, the while loop will stop when the current wallet is larger than 2 times the initial wallet. Right. So now we need to make the implementation of computing each year's how our wallet evolves, considering the interest rate. So a little bit of math would tell us that our current wallet at the beginning of the new year should be equal to the current wallet at the end of the year, where you add the interest rate on that current wallet. So it would be current wallet plus current wallet times interest rate. Great. And we mustn't forget to crank up the years because we want to count how many years and know that afterwards. So here I should say that years is equal to years plus 1. Great. So you see what I've written is a bit redundant. So let's clean this a bit. So this, if I would make it a bit more math efficient, I should really factorize and simply put here a times, open a parenthesis, 1 plus interest rate. Great. Let me remove that extra indentation. And actually, let me show you something else. A little shortened notation in Python is this plus equal 1. This years plus equal 1 is exactly the same as writing this. And in the same way, you can do minus equal, times equal, and division equal. So let's keep it like this and remove these. And that's what we have here. Great. Let's add maybe a little print so we track what is going on as the loop goes on. So let's do print. And how should we put it? Well, let's say my investment is worth. So I'll put a comma here and I'll put current wallet. And then I'll say on year, and then I'll put here comma years. Okay, let's run that and see how it goes. Great. And what do we see? It actually took 15 years to double our investment with those starting parameters here. Something else you should notice here is the power of compound interest. Indeed, after year 1, we got exactly $50, which is the 5% of our initial wallet that was $1,000. But then the year after, it wasn't $1,050 plus another $50. No, it was 5% of what we had on year 1. So we have a little more than $50. We have 52.5. But then this cranks up, and you can see that by the end, the compounding interest does a lot. Without the compounding interest, it would have taken us actually 20 years to get to the double of that investment. Anyway, back to our while loop. So the question is, why did I go for a while loop here and not a for loop like before? Well, because there was no way of knowing how long this computation would take. Indeed, the question we were trying to answer is how many years it would take us to double the investment. So this 15 here, we didn't know it beforehand. So there was no way of doing like for I in range 16, 15, whatever. We don't have that. So that's why we went for the while loop. Let me actually show you that indeed it did exit just after having finished at this point here. Because indeed you notice that now our result at this point is $2,078, which is indeed above 2 times our initial wallet, which should be 2,000. So the while loop indeed did the computation until this condition was not verified. Because at the beginning of the next step, it did the check and it saw 2072 is no longer smaller than 2 times initial wallet, so 2000. So I'm not doing that step anymore. I'm exiting the loop. So I said I would show that it exited the loop. So let's print something here. And let's say, for example, I'm actually going to do double quotation marks. So I show you that now I can actually use a single quotation mark in my sentence. So I'll write, that's it, guys. Okay, so let me run that. And indeed, as you can see, it indeed exited exactly when it should. Great. We can totally now do 3. And again, it will do the computation for us. How many years will that take? Well, it takes 23 years. So you can also see, by the way, again, the superpower of compound interest. It took 15 years to double, but then it took only an extra 8 years to triple. And this is really thanks to the compounding interest. By the way, I didn't explain what compound interest is. It is simply the fact of reinvesting the interest that you earned on your investment again and again.
Okay, we have started to see the use of conditions with this while loop. So let's have a look at them in more details now.
There exist essentially 3 fundamental structures to test conditions in Python. And these are the if, the elif, which stands for else if, and the else. So in this little exercise to illustrate those concepts, we're testing basically the Bitcoin price. And depending on its price, different actions will be taken. So first of all, we're testing if the price is smaller or equal to 30,000, then we print a buy. But if the Bitcoin price is larger than 30,000 and smaller or equal to 50,000, then we print sell half. Then another option we're testing, if it is smaller than 60,000, we print hold. And if it is none of the above, then we print sell all. Note that I didn't specify a lower bound here, and I don't need to, because the way Python works is that it tests this first condition first. If this is not verified, it looks into the other one. If that one is not verified, it looks into the other one again, etc. So it would only come up to this condition if and only if those 2 conditions were not met. And so the lower bound is included in those conditions here. So you understand now that the way to read this, for example, is to say, if this condition here is true, then do that. And this do that is now characterized exactly like what we saw in the for or while loop. This is indeed a child block of this parent block. So you have this indentation here. So this does signal that this belongs to this if structure. And if this condition is false, then it goes to the second test, which is saying else if, or you could say then if Bitcoin price is this, and you see the use of an and operator here, Bitcoin price smaller or equal than 50, etc. Then it does this. Then it tests this, etc., etc. If none of these work, then it goes to this all else case, print sell all. Okay, so let's actually now run that cell so we see what comes out of it. And surprising or not, we get print sell half, which makes total sense because 45,000 is indeed above 30,000, but below 50,000. Now, what would we get if I put actually 30,000 here? Well, we get buy because we did indeed put a inferior or equal here. And note, by the way, that the equal is always put after the inferior or superior sign like this, not the other way around. Great. If we wanted to test maybe something that would come into here, so it would have to be larger than 50,000. So, okay, so if we did 52,000, what would that give us? Hold, very good. And let's now say that the price of Bitcoin went completely crazy. And indeed, we get sell all. Great. Yeah, I gave you an example where I use all of these structures, if, elif, else, but you actually don't need to use all of this. You could simply define a if like this. And indeed, if I run this, absolutely nothing happens because at this point it tests the price, but the condition is not true. So there's no print buy and actually nothing happens. You could also do just if and else. So now if I run this, we do have the sell all again. And in the same way, I could comment that and leave that uncommented and run it. and nothing happens, again, because we're not within these conditions, but let me put it back into these conditions, and let's say 40,000, and then this would go in the elif, and we have cell half. Good. Here's another example where I show you the use of conditions with strings and different operators. So let's go through it together. So in the first line, what I do is to attribute the value hello, the string hello, to the variable text. And then I test if text is equal to hello or text is equal to hi. As you can see, very important to test for the equality of something, you use the operator equal in Python. And the single equal is indeed reserved to defining a variable, or better said, to attributing a value to a variable. Okay, so if text is hello or text is hi, and as you can see here, the same way we saw the AND operator, we also have the OR operator in Python. So basically here, if either of these two conditions is met, then you get this print here. And if not, we're doing also an else if test, and this time it is written text is not equal to hello. So the exclamation mark followed by an equal in Python is the operator not equal to. And if this condition is met, then we get this print here. Okay, so let's run the cell and see what we get. Text is hello or hi. Well, that makes sense. Indeed, text was hello. Therefore, we verify this condition, and therefore we get this print that is displayed. Great. So in the same way, if we had a hi here, what would we get? The exact same thing, because now we verified this condition, so we get this print. Great. Now, what would happen if I said, well, hey, as I'm sure you might have guessed, we get text is neither hello nor hi because it is not equal to hello. Now, what would happen if I put a if here and I put a hi here? What would we get? We get both. We get text is hello or hi because indeed hi is either hello or hi, but it is also not equal to hello. So this if is tested and we have this second line. So you see, this is quite important. Be careful of the difference between if and else if or elif. One more little example, and here I wanted to illustrate the use of booleans. So I remind you, a boolean is either true or false. So let's say I have a condition that is here equal to true, but what I want to do is test whether it is true or whether it is false. So I can totally write if condition is true. Actually, you could here put a equal, but it is better practice with booleans to use is. Okay, so if I run this cell, naturally I have my condition is true. And if I put a false here, naturally what would I get? My condition is false. One thing that I could add is that you actually, to test if something is true, you don't need to do is true. There is a shortcut in Python, and if you say if condition, it understands if condition is true. So let me show you that. My condition is true. Great. Let me also show you the use of the operator not. So let me write it like this, and then put a false here. So you can see you can test is, but you can also do the opposite test, which is not. So let's run that. What do we get? My condition is true. Indeed, condition is false, so condition is not true. Anyway, let me put back just is true for now. Indeed, this was a bit of a silly example, but just note that you can define more involved condition. So let's say condition is equal to A larger than B. And let's say just before that, we say that A is equal to 2 and B is equal to 1. What should we get out of this? My condition is true because indeed A is larger than B. This indeed, by the way, now resembles exactly what we did in this case here, the same kind.
Great. I think it is time we look at a more intricate and realistic example, and we mix a bit of everything, loops and conditions.
What this example does here is that it computes the amount of months required to reach a savings goal, but with the little subtlety that after a certain amount of months, we will get a raise on our salary, which will allow us to increase our monthly savings. So the variables that we define are the saving goals. We say 10,000. The monthly savings are 400, but after 6 months, we get our raise, and therefore we can increase our monthly savings from 400 to 600 because our raise amount is 200. Next step is to define our counter, to initialize our counter. So of course we need to check how many months are going, because at some point the raise will happen. And then of course we also need to count what our total savings are as the months go. Then this is also a problem totally suited for a while loop. So what we will do is simply run the while loop until total savings becomes larger than savings goal. And what do we do first in this while loop? Well, first of all, we need to check whether the raise has happened or not. So we're checking if months required is equal to month raise. And if it is indeed equal, then we're cranking up the monthly savings by this raise amount. Remember the use of the plus equal operator that I told you before. And whether this condition is implemented or not, what we do at each loop is that total savings is also cranked by the monthly saving each month. And finally, we also need to increment by 1 our months counter. So that's why we have months required plus equal 1. By the way, I've just realized I think I've never explained what these are. So indeed, you see their text, but this is text that is not run by the code. It is what is called a comment. So this is basically text that you write to help you understand what's going on in the code. It's very important to comment your codes properly. So if you look into it later on, or if somebody else looks into it, he kind of understands what's going on in your code. So how do you do a comment? Well, you start with this symbol here, and then you write your text. Actually, there's 2 ways. You could write the symbol first, but you can also always write the text first. Let's say blah, blah, blah. And then on VS Code, what you can do is a control /, like so. And to uncomment, you do a control / again. And that doesn't have to be at the end of the line. You can do it wherever is your cursor. Great. Anyway, back to our loop now. And you can see that once the loop is finished, I print the results with this little print here. So I'd suggest we simply run the code and see what comes out of it. And you see, we will need 19 months to reach our savings goal of $1,000. And actually, if we can save more per month, this would increase as well. Now, 14 months we have with 600 per month savings. And if, on the contrary, we would get our raise sooner, let's say after 2 months, same thing. It should reduce the amount of months as compared to the first example, 18 months. Great. On the contrary, if we have the same number of months, but we do only 100 with our raise because our boss is a bit stingy, well, it is longer. It takes longer, 21 months. Anyway, let me put some prints in the loop so we can track what happens and how it works. So let me go back to the previous example, 400, 4 months, 200. Great. So let me do, to see when this triggers, let me put a print here and I will do, I got a raise. Yes. Okay. That's for that. Unless at the end of the while loop, print the months required. So that our months counter basically. And let's also track our total savings. Okay. So let me run this. And what do we see? Indeed, after 4 months have passed, I have finally my raise. So you see beforehand between month 3 and 4, the difference is 400, same between 2 and 3, etc. That concurs with the fact that we're saving 400 at first. But as soon as I got the raise, you can see that from month 4 to month 5, the difference is now 600. And it carries on like this. 5 to 6, we also have 600, etc. Until we get to the month 18, where we finally reach our goal. Nice.
Hey, maybe this feels like a lot, but don't worry. With practice, it does become easy. So let me now give you some homework so you can train by yourself.
As usual, you can find it on our website, and you will also find a link to a possible correction of this exercise, but I really recommend you do as much as you can without looking into it. So basically in this exercise, you have invested €1,000 in a mix of financial assets, and you want to understand how long it will take you to get to your capitalization goal, depending on some parameters. So the first question is basically how many years it will take you to get to this capitalization goal. So this does indeed really resemble something that we've already done together. So it should be okay. Anyway, second question, change a bit this annual interest rate and see how it affects the amount of years it takes you to get to your goal. So play a bit with that. And finally, do the same thing, but in a more programmer's way. So basically do a for loop where you test different types of annual interest rate. from 2 to 8% with a step of 1% and display these results nicely.
Okay, it's all up to you now. You have all the keys to handle loops and conditions. And I'll see you next time to talk lists and dictionaries. Don't forget to support us with a little like and a subscription, and share this course with anybody who might like it. Take care.